So the topic for the day is on the bilge systems. We would be specifically dealing about the engine room bilge pumping system and the problems faced in it. So here is a simple diagrammatic representation of the engine room bilge system. So with this system we would be addressing the basic engine room bilge system components, the problems which we usually encounter, the maintenance which we carry out throughout the bilge system, and what you do when you have a hole in the bilge line, or how do you identify it, which is usually asked in the orals. So with that in mind, we'll start with the understanding of this simple line diagram. Here's the bilge main, and this bilge main is the one which runs almost the length of the engine room, right from the forward of the engine room to aft of the engine room, which is similar to the spinal cord of a human body, and with respect to the bilge system. Alright, so with that we have various branch lines connecting to the various bilge wells. Let's say forward starboard bilge well with a strainer here, and with the angular non-return valve, screw-down non-return valve usually, and the forward port side bilge well, aft starboard and aft port, and main engine sunken bilge well, and the cofferdam bilge suction. So usually these are the things which you can find. If you have a duct keel, then definitely you will be having the duct keel bilge suction. So these are the branches which are connected to the bilge main, and you have one more important connection is usually with a valve you have a blank fitted, or you can have a ready-made snap-on coupling for either compressed air or fresh water from the hydrofor. So compressed air from the ship's compressed air system, and the fresh water is from the hydrofor. So you all know that there must be some freshwater service and compressed air service lines on the bottom platform. So we can just put a hose, flexible hose, and connect it, snap either freshwater and compressed air, and you can use it. And we will see the purpose of this later after understanding the system. And then the bilge main is connected to the pump by a screw-down non-return valve. This is very, very important. And after that we have a strainer or the suction filter for the bilge pump, and the bilge pump is usually a reciprocating or a positive displacement pump. It can be either a reciprocating pump, or sometimes you can find a single screw mono pump. So on the discharge you have a valve and 2 or 3 valves isolating that one line which is going to the bilge holding tank and other line which is going to the shore. And you might be having sometimes an interconnection to the incinerator waste oil tank, but it is subject to the approval of the classification society. So the reason why bilge line or bilge pump discharge is given to the incinerator waste oil tank is to undergo a process called as decanting or evaporation. So all the pipeline, that is the main thing, is the bilge pipeline, or every pipeline in engine room, every line system has to be class approved. So if the class approves this system, you cannot have any other connection apart from this system. If so, it's violation. So apart from that, we also have a seawater connection, and most of the modern ships don't have this connection, but no wonder you can find one. So you have a valve for that. And that's it about the bilge system. And one important component is there will be an interconnection between the bilge line and to the suction of the fire and GS pump, which I have not shown in this diagram. And you can also refer to solas for the diameter of the bilge main. The bilge main cannot be of any diameter. It has a separate formula which is detailed in solas. Please refer to that. You might be asked in the orals either. So with respect to that, then we will go to various problems which we usually face. There might be different problems occurring on various types of ships. So generally we encounter that the pump is not taking suction, either the filter is getting choked or hole in the pipeline or loss of vacuum or too much of vacuum, or the pump is not discharging because of, let's say, too much of steam being open to the bilge holding tank, etc., water being flashing away. So that's the normally encountered problem on board a ship with respect to the bilge system. And with respect to maintenance, let's start from the strainer on each and every bilge well. So it's a best practice to have an engine room filter cleaning schedule. Usually monthly once you got to clean all the strainers on the bilge well. So it's just a mud box filter, or we can call it as a strum box. You got to remove, and we have a very coarse filter here. Some ships have the habit of fixing a felt filter over here so that you can extend the life of this strainer. And after that, you got to, after boxing up the mud box or the strum box, it's customary to apply some grease on the mating surface of the top cover and the body of the filter so that no escape or ingress of air into the bilge system is encountered. Usually there will be an O-ring on the filter. You got to check the condition of it. And one important aspect about the cover of the filter is that the cover is very, very heavy. It's too heavy when compared to other filter covers. The reason for that is the natural gravity sealing which can be maintained upon the O-ring. So that's it about the filters. And the pressure testing of the bilge line, which has to be done regularly. So the pressure testing can be done usually when the ship is at port during any non-critical operation. Like you can't do it at the cargo operation, as let's say for some reason the pipe gets holed and as you open the seawater some mishap happens and the engine room is getting flooded. So for safety reasons you don't do it in sailing or when the ship is undergoing some critical operation. And after that, with respect to this strainer, obviously the same, whatever we have done, we got to clean this filter and apply some grease on the cover. And after that, the bilge pump. Yes, you got to monitor the performance of this pump regularly, like as the discharge or the pumping rate keeps on decreasing, then you got to overhaul this pump. The stator and rotor must have worn with respect to each other. And sometimes if you have a reciprocating bucket type valve pumps, some contaminants might get stuck inside the valves, so that the suction and discharge gets recycled and no more pumping action will take place. And that's about maintenance. And let's now see, how do you find out when there is a hole in the bilge line, which is a common question asked in the oral examinations. For that, the first thing what you have to do is isolate the bilge main line. Let's assume you have a hole over here in this part, which is shown the arrow mark. I mean here, in the computer I'm showing an arrow mark. So this place we have a hole, we don't know. So what we have to do is isolate the bilge main, the system, completely from the pump. So shut this valve and shut the forward starboard bilge well valve, this one, shut this valve and shut this valve, shut this, shut all the bilge well valves. And now you can do either seawater method or the compressed air or freshwater connection. Either of these two, depending upon the availability of your shipboard system, you can do it. Let's assume now I'm going to fill up with seawater. So since this is going to be a screw down non-return valve, when you open the seawater line, the water will not come in. So what you have to do is shut the seawater valve, open the bonnet or the top cover of this valve, take out the valve lid or the valve itself, and then without the valve lid just box back the valve and bolt it and tighten it to the torque. And after that, open the seawater slowly, and then you can see that seawater is getting filled up throughout the line. So literally you got to get down to the bilges and trace each and every pipe, touch it and see and feel it where exactly the water is leaking. And if we approach this place and you find some water is coming out of this, then definitely there is a leak over here. So that's how we can do with the seawater connection. You need not pressurize the line completely, as the seawater discharge pressure will be of the order of, let's say, 1.5 to 2.5 bar for sure. So I think 2 bar is sufficient enough to locate a leakage. And after that, so now assume that you don't have a seawater connection, so you got to find the hole with the help of a compressed air or freshwater connection, which is common over here. So definitely out of these two you will be having one with respect to the Bilge system. So now what you're going to do is shut this valve, and this one you need not remove the valve lid, so you can just put it and shut it completely, and shut the individual bilge well suction valves. And now what you're going to do is connect the freshwater hose and then fill the line with fresh water. And the freshwater, as you all know, the freshwater supply is from the hydrofor, which is usually operating at 7 bar, but we don't require that much pressure. So just throttle the valve, adjust this valve so that you can keep the pressure, let's say 1 to 2 bar. Obviously you got to fabricate a pressure regulator and a pressure gauge connection just to check how much is the pressure. You can't overload or pressurize the line than which is designed for. So usually these these pipelines are designed for 5 bar or 10 bar. Refer to the pipeline diagram book, which clearly states how much pressure these pipes can hold. So I don't want to comment on it because every ship has its own individual structure. So with the help of pressure regulator and pressure gauge, fill the line with fresh water, let's say 1 bar or 2 bar, and once the water is filled, shut this valve and then connect the compressed air line, again with the help of pressure regulator. Adjust the pressure to 1 or 2 bar, pressurize the line. Now when you trace, now it's recommended that 2 or 3 people get down to the bilges and trace individually so that you can be quick in finding where the leakage occurs with the help of fresh water coming out. You can directly put compressed air, but with the compressed air you can miss it out. You know, it's just air, so you can, if you have a little bit of less sense, you can easily miss it out. So it is always advised that you put some water and pressurize it so that you can see the water oozing out of the leak. Even minute crack, a pinhole can be detected with water. So then when you pressurize, when you approach this line, you can find out the leak over here. And let's say if the leak appears after this valve, then you can shut all the bilge valves and then open one by one. Let's say you open this valve. If the pump takes suction, this is okay. Then if you keep this open and keep this open, if the pump takes suction with this, then also these two lines are okay. Then we know that the crack is over here. So when you open this valve, now the pump doesn't take suction because the air is getting inside and then it's going. So you can suspect this, but anyway, we all know that the crack is over here. So if we start the pump with this valve and this valve open, definitely the pump is not going to take suction, as the air can get inside and then the pump loses its suction. And so after that you got to isolate this valve and try out the pump again. So now the pump takes suction, so you're sure that you have a leak over this pipeline. So that's it with respect to the Bilge system. So thank you all for watching this video. For more videos, log on to dieselship.com.